All right, everybody, welcome back. Got a really short lesson today on stream dynamics. And what I mean by that are mainly how streams affect the stream bed beneath it. And so we're going to take a look at some diagrams from top views and side views, and hopefully we can make some sense of this. All right, what we're looking at here, stream velocity in a straight channel. We already learned this before with glaciers, but the fastest movement is in the middle, just below the surface. So in this diagram here, you can see where the letter X is located. That is the fastest flow. Okay, and the reason why it's slow over here has to do with friction with the surface, the stream bed. So there's friction all along this part. There's a little bit of air friction perhaps up here. So the fastest flow is either here, somewhere in this area. Now in a top view, you can see how they represent that with different length arrows. So you see the fastest flow right down the middle, and on the sides where there's the most friction with the side, the banks of the stream, it looks like that. So a pretty straightforward picture here. Three factors affecting a stream's velocity. Now we already learned about slope or gradient of a stream. Obviously the steeper, the faster it's going to flow. But this is a new term here, discharge. Discharge just means how much water is actually in the stream or the river. It's the volume of water. And obviously after a rainstorm or a snow melt, you're going to have a lot more discharge and the river's going to go faster. The shape of the stream channel also has an effect on how fast it flows. If it all of a sudden gets narrow for some reason, it's going to speed up. And then if the stream channel widens out, it's going to slow down. Or if it gets shallow all of a sudden, it's going to speed up, maybe make some rapids. And if it gets deeper, you're going to notice it'll slow down. There's more room for it to flow. The velocity changes in an S-shaped curve of a stream. These are called meanders, these S-shaped curves. And you must know that they move fastest on the outside of the curve, and this is where erosion is going to occur. And the opposite happens on the inside, where streams slow down, and that's where deposition or the dropping of sediments occur. So here in this diagram, we see a stream, and this arrow represents a faster flow on the outside of the curve, slower on the inside. And so this faster flow right here, it has enough energy to erode the stream bank on this edge, and also over here in the side view, it erodes more on the right-hand side. So this area gets deeper compared to the area over here. Now on the inside of the curve, where deposition is dominant, where the stream slows down, it's moving slower. And this slow movement allows some of those particles, especially the larger ones, to deposit out, to settle out. And that's why less erosion happens over here, and instead it starts to pile up sediment. They actually call this thing the cut bank because the water cuts into the outside of the curves of the stream bank. And you'll notice in real life they'll collapse in. You'll see trees falling over, different states of collapse of a stream bank. On the inside of the curve, this is called the point bar. And often you'll find gravel, you'll find sand, perhaps a sandbar, something like that. And over time, this stream bed is going to migrate, this curve is going to migrate in this general direction. So this is going to build up, but this is going to erode away, and the whole curve is going to move farther to the right. Hopefully that makes sense. I know it's a lot of writing. All right, looks like my writing stayed on the board. Let's practice some of these things on the whiteboard in class and see how it goes.